3.4 is symmetries of graphs. So first of all, we have line symmetry, and this is reflection symmetry. Oops, sorry about that. Reflection symmetry over a line. And so we're talking about like a mirror image. Point symmetry is rotation symmetry around a point. We're talking 180-degree rotation symmetry. So if we look at these graphs, we have y equals x squared, and this, as far as symmetry, reflection symmetry is typically pretty easy to see. Basically, if you fold over the y-axis here, we would have the same shape. You could reflect it over that line. So this has line symmetry. B also has line symmetry because you could reflect over the y-axis. This line is kind of different because technically you could reflect over this line, so it has line symmetry. But you could also reflect 180 degrees, or I'm sorry, rotate 180 degrees. Like if you kind of think about like flipping the graph around, you would have the same graph again. So it actually has line and point symmetry. So let's talk about even and odd functions. So in general, a function's an even function if for all values of x, f of negative x equals f of x. What this means, let's say we have the graph of y equals x squared. If you put 1 into the equation, you get 1. If you put negative 1 in the equation, you also get 1. Okay? So even if you put in a negative value, you get the same y value. For an odd function, if we look at y equals x cubed, if you put in a 1, you get 1. You put in a negative 1, you get negative 1. Okay? And basically looking at this, even functions have line symmetry, odd functions have point symmetry. That's another way to think about it. Okay? Again, this is point and line. This is really just another way of showing what we just did. So if we want to figure out if a function is odd, even, or neither, we're going to check f of negative x and see what happens. See if we get the same thing, see if all the values are negative, or see if something weird happens, then it would be neither. So f of negative x, we would have 4 times negative x minus 2 times negative x cubed. So which is negative 4x. Basically negative 2 times negative x cubed. So it would be a negative 2 times just negative x cubed, because negative 1 cubed is negative 1. And so this is negative 4x plus 2x cubed. And basically, since if you compare, in this function we had positive and now we have negative and positive, this must be an odd function, because f of negative x has all opposite signs in the coefficients. Now let's look at x cubed minus 5x. So we're going to check f of negative x again. So f of negative x is negative x cubed minus 5 times negative x, which is negative x cubed plus 5x. Let's look. So we had positive, negative, and now we have negative, positive. So it's odd again. f of negative x has all opposite signs. Okay, so if we put in a negative x and got the same function, it would be even. If we get all opposite signs, it's negative. If something else weird happened, it would be neither. Okay, so keep in mind, odd functions. This means that if you have the point x, y, you would also have the point negative x, negative y. Okay, so if you put in a negative x, you get a negative y. If you have an even function, you're going to have the point x, y, and if you put in a negative x, you'll also get y. So you'll have x, y, and negative x, y. So for this example, we have the point 3, 5. If the graph is odd, if we put in a negative 3, we'll get a negative 5. If it's even, we'll put in a negative 3 and the y won't change, so we still have a 5. Pause the video for a second and do this example 2b right here. So basically, if it's odd, we put in a negative 1, we should get a positive 2, sign flips. If it's even, if we put in a negative 1, our y value shouldn't change, so we still have negative 2. Okay, so now we'll look at some graphs. We'll deal with our parent functions a little bit. So if we have this function here, we're giving the equations for asymptotes and symmetry. Well, first, the parent is definitely going to be y equals 1 over x squared, which is inverse square, which looks like that. And then what happens, basically, is we're translating this. It's the opposite of what you see here, right? So it's x minus 3, and this is matching, right? So it's y minus 7, okay? So the 3 is the opposite of what it looks like in the equation, or the x piece. And so that means when we make our new graph, instead of at 0, 0, we're going to move over to 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Let's say that's negative 7. Okay, so here's our new asymptotes, and now our function will be here. So the asymptotes are x equals negative 3 and y equals negative 7. Again, they're right here, okay, negative 3 and negative 7. And as far as a point of symmetry, we're going to have line symmetry because it's even, and honestly, you can just look at it. There's going to be symmetry about this line, okay? And then you're like, oh, it's vertical, so it's the line x equals negative 3. For this next one, the parent, we're doing the same thing. So if you'd like to pause it and try on your own, you can, or you can just keep watching and not pause it. The parent is going to be 1 over x, because I see something over something. There's no square, right? And so this is inverse variation, which looks like this. As soon as we translate it, we're going x plus 8, 8 to the right, so the opposite of what you see. You see negative, so we're doing positive. And then y plus 9.5, okay, because that's the same as how it looks. So then our new asymptotes, we're basically moving our center to 8, 9.5, let's say here, okay? We'll make our asymptotes, and our graph is here. And so the asymptotes then are x equals 8, and y equals 9.5, okay? And then it's going to be symmetrical. Instead of about the origin, like here, it's going to be symmetrical about that point, which is the point 8, 9.5. So judging by the type of symmetry then, example 3a was even because it has line symmetry, and example 3b is odd because it has point symmetry.